Okay. So, since the resultant force is equal to 0, then Rx is equal to 0, and the Ry is equal to 0. So, let us try to determine now the components of the 30-pound force. So, your Fx is equal to, so 30, so this one in here is 45, so that one is 45. So, that is 30 cosine of 45, 21.213, and your Fy is 30 sine of 45, or that is 21.213 pounds. So, first, so we now have your Fx, and that is now your Fy. So, again, this is your F1x, and that is your F1y. So, we have your F2, we have your 60 pounds directed along the x-axis at point C. So, let us try to determine the value of x and y. So, we have, this is your point O, and this is now your point B. Now, the radius of the wheel is 0.75, and OB in here is the radius, and that is 0.75. So, we have your 45 degrees. So, if you try to get cosine of 45, x all over 0.75, or your x is equal to 0.53 feet. And sine of 45 is equal to y all over 0.75, hence your y is 0.53. And let us try to determine now your x1 and that of your y1. So, this is your O, and that is now your point A. So, OA is the radius of the wheel, which is 0.75. So, if you try to get cosine of 30 degrees, x1 all over 0.75, your x1 is 0.65. And sine of 30 degrees is y1 over 0.75, your y1 is 0.375. Now, let us try to determine now the moment of the resultant about point A. And this is equal to the summation of moment of all the forces in the system about the same point A. Now, since the resultant is equal to 0, hence, its moment about point A is equal to 0. So, we have now to assuming counterclockwise moment as positive, so we have a counterclockwise moment or couple acting at point O, so we have positive AT. So your 60 pounds will have a clockwise moment about point A, and we now have this perpendicular distance from the line of action to the moment center is y1. And then we have your Fy is going into a clockwise moment about point A, and Fx is going into a clockwise moment about point A. So, your Fx is 21.213, the moment arm. So, this is the line of action, and this distance in here is equal to y minus y1. So, that is the perpendicular distance from the line of action of Fx about point A. And we have now your Fy is still going clockwise about point A. So, it's 21.213. So, this is the moment center, and that is x plus x1. And then minus F2, and the moment arm about point A is the moment arm about point A is equal to 0.75 plus, so that's 0.75 plus y1. So that's 0.75 plus y1. So that is 0.75 plus y1. That is 0.75 plus y1 is the moment of F2 about point A. So it's 0.75 and y1 is equal to 0.375. Okay, so we have the algebraic sum of this is equal to 29.181 minus 1.125 f sub 2. Hence, your f sub 2 is 25.939 pounds. Now, let us try to determine now the value of F1. Now, Rx is equal to summation of forces along in the x direction. I'm going to consider to the right forces as positive. Since the resultant force is equal to 0, then Rx is equal to 0. Then we now have, so let's start with, F2 is going to the right, and your F2 is already computed, and that is 25.939 pounds. So it's going to the right, so we have 25.939 pounds. And then plus 60. Okay, so minus 21.213 or minus Fx 213. And then we have this going to the left, F1x, so minus F1x. And therefore, your F1x is now equal to 64.726 pounds. Now, Ry is equal to summation of forces along in the direction of y, and this upward forces, and as I to consider that upward forces are positive. Again, since the resultant is equal to 0, then Ry is also equal to 0. So we have, so this one in here is going downward. Fy, which is 21.213. So that is your Fy. Plus F1y plus F1y. Hence, your F1y is now equal to 21.213 pounds. Let us try to determine now the value of. So let us try to determine the value of, or the magnitude of F1 and the direction of F1. So your F1 therefore is now equal to the square root of F1x squared. So we have 64.726 squared plus F1y squared 21.213 squared. So your F1 in here is now equal to 68. Okay, so this is F1 is equal to 68.113 pounds. So your theta in here is now equal to, so we have your F1. This is now your F1. That is your F1. This is now your f of x. F1x, and this is now your F1y. F1y, this is your F1x, and that is now your angle theta. So we now have your tangent of theta is now equal to F1y all over F1x. So that your theta is now equal to the arc tangent of F1y, which is 21.213 all over F1x, which is 64.726. So your theta is equal to, we have 18.15 degrees. So your F1, which is equal to 68.113 pounds, makes an angle of 18.15 degrees with the in the x direction. So problem number 4. Determine the magnitude and direction of force F and the couple moment such that, okay, so we have a couple moment M such that the loading system is equivalent to a resultant force of 600 newtons acting vertically downward at O, and the clockwise couple moment of 4,000 Newton meter. Okay, so the original system okay, so this, we replace this one. Okay, so this is your point O. So the equivalent force system of the original system is having a resultant force of 600 Newton acting vertically downward at O. So this is therefore the resultant force, which is equal to a 600 Newton. And a clockwise couple, which is equal to, so we have a clockwise couple, which is equal to 4,000 Newton meter. So first, let's try to determine the components of the 800 Newton force. Okay, so this is making an angle of 60 degrees with the horizontal. Now, the components S or R, Fx is equal to 800 cosine of 60 degrees, or this is equal to 400 newtons. And then Fy is now equal to 800, we have sine of 60 degrees, and that one is equal to, so that is the x component, and we have the y component. So the x component is included, 800 is included in the x-axis, so we have cosine. And we have your Fy is 800 sine of 60. And 800 sine of 60 is 692.82 newtons. Okay, so let us try to have now this, therefore, so we have your point O. We have this is your F1y, and this is your F1x. We have Fx. So this is your Fx. And this one is now your Fy. So we have now your 300 Newton. This is the 300 Newton. And then we have your moment. And we now have your 800, the component of the 800 Newton force. So this one and this one. So your Fx in here is 400, and your Fy, so that is your Fx. And your Fy is equal to 692.82 newtons. So we have now the distances. So from point O is 2 meters, and that one is 1 meter. This is 0.5. That is another 0.5 meter. We have couple M. Okay. Now, since the resultant R is directed vertically, the resultant R, so this is now the resultant R. So that is, since R is vertical, so it is directed vertically, then Rx is equal to 0, and Ry is now equal to R. So let us try to determine now the resultant. Let's try to determine now your magnitude, or the magnitude of F. Your Rx is equal to summation of forces along the x, or in the direction of the x-axis. Since Rx is equal to 0, then we have Fx is going to the right, so we have Fx. And the 400, so we have minus 400, and therefore your Fx is now equal to 400 newtons. Your Ry is equal to summation of forces in the direction of the y-axis. So in here, I will going to consider this is going upward forces are positive. So we have the resultant is directed vertically downward. So we have minus 600. And this is equal to minus Fy. So we have minus Fy plus 300 minus 692.82 newtons. And therefore, your Fy is now equal to, so the value of Fy is equal to 207.18 newtons. That is 207.18 newtons. So that is this. Transpose this to the other side of the equation. So your Fy is 207.18 newtons. And therefore, the value of F is now equal to the square root of Fx square plus Fy square, and your F is now equal to 450.47 newtons. 450.47 newtons. So that is the value of F. Let us try again to determine angle theta. So again, your theta is now equal to the arctangent of Fy all over Fx. So this is equal to the arctangent. Fy is 207.18 over Fx, which is 400 newtons. So your theta is now equal to 27.38 degrees. Let us try to determine now the magnitude of M. So if you try to determine now the magnitude of M. So the magnitude of M is now the moment of the resultant about point O is now equal to the summation of moment of all the forces in the original system about the same point O. So I will going to consider clockwise moment as positive. Okay, the moment of the resultant, the 600 Newton. Okay, so this system in here was replaced by a resultant and a couple at point O. The resultant passes through point O. So we have the 4,000 Newton meter couple. So that is 4,000. So clockwise is positive. And this is therefore equal to, we have your about point O, Fx. This Fx has no moment about point O because it passes through your moment center. So we have Fy is clockwise. So we have positive Fy, and the value of Fy is 207.18. So the moment arm is 2 meters. We have the moment arm is 2 meters. Then we have the 300 is going counterclockwise. So it's negative because we assume clockwise to be positive. Now the moment arm is 2 plus 1. And this one is now equal to 3. So we have plus m, that's clockwise moment. And then your Fx in here has no moment about point O because it passes through your moment center. So this one is going clockwise about point O. So that is minus 692.82. The moment arm is equal to 4. 2, 1.5, and 0.5. So that is equal to 4. Hence, your m in here is now equal to 1714. Is 1714.36 Newton meter.